Welcome to solverfy.
All right, so here we have the same algorithm under two conditions. The first is that it will not be sorted, but we're looking for finding the closest two numbers, right? Which is really just finding the distance between them. So I'm going to call this algorithm closest, and we need a list of n real valued numbers. And in order to have a distance, we need at least two elements. Okay, so there must be at least two elements in this list. So first, I'm going to initialize some parameters. So we'll set k equal to 1, the first index. We'll set L equal to 2, the second index. And then we're going to set M equal to their distance. Okay, so that's just going to be a2 minus a1. And then we want the absolute value of this distance, because distance should be positive. So then we're going to start iterating through every possible pair in this list. So we'll have 4i as it runs from 1 to n. And then we'll have a nested list. So in this case, we're going to have, we'll say j. This one's going to run from I plus 1 to n, right? And so what's happening here is that when I is equal to 1, it'll be at a sub 1, and then it's going to compare a sub 1 to a sub 2, a3, a4, a5, a6, a7, etc. And then it's going to jump to a2, and then it'll compare a sub 2 to a sub 3, a4, a5, a6, all the way. Okay, so this is going to allow us to compare every pair of them. And we want to check their distance. Okay, so we'll say if, and we want the absolute value here, a sub j minus a sub I is less than m, then we will reset k equal to I, L equal to j, and m is now going to be equal to the absolute value of a sub j minus a sub I. And so once it's gone through and made this comparison with every pair of numbers in this list, then we want to return a sub I and a sub j. So we are finding the two closest numbers. Okay, and then it wants us to do the same problem, but with a sorted list. Okay, so in this case, we're still looking for the closest, but we're sorting it, so I'm going to call it closest sort. And we're getting the same list of numbers. Which are real numbers, and the same rule applies where we need at least two of them in order to have a distance or a closest. Okay, and so the first thing then that we want to do is sort the list. Okay, so we're going to sort it. And so now our list is such that A1 is less than or equal to A2, which is less than or equal to A3, so on and so forth. So I'm just going to make a little note here. Now that A1 is less than or equal to A2 all the way up to AN. Great, but then it's going to start off, roughly the same. We want to initialize some things. So we'll set K equal to our first index, L equal to the second index, and M. And this time we don't actually need the absolute values, right? Because we know that the index with a higher subscript should be greater than or equal to the one with a lower subscript. So the lowest value this difference could take is 0. Okay. And then we go through and we want to iterate through the list of pairs. But this time we don't need a nested loop. So we just need I equal from 1. I apologize, from 2 to n. And because we know that the difference between A1 and A3 is equal to or greater than the distance between A2 to A3. So we don't need to check all of those pairs. All right, but then it's going to continue in sort of the expected way as before. So we'll say if AI minus AI minus 1. So if this current value, if you subtract the previous element in the list, is going to be less than M, then we will reset all of our conditions, right? So we're going to reset L will be equal to I, K will be equal to I minus 1, and then M we will set to the new closest difference of AI minus AI minus 1. Okay, and then at the end of this, we want to again return the elements that are closest together. So we'll do that by returning a L and A